Chapter 11, Liquids and Solids. Exercise 11.91. 4 ice cubes at 0 degrees Celsius with a total mass of 54 grams are combined with 115 grams of water at 90 degrees. We have enthalpy of fusion 6.02 kilojoule per mole, and the specific heat capacity of water, so supposedly it should be C sub S. This is a mistake. Now let's look at the question. Part A, if no heat is lost, what's the final temperature? Let's say the final temperature is X degrees Celsius, and then we'll set up the equations. Alright, so let's say the final temperature is X. When we analyze this question, number one, we need to know that this ice cubes will melt first into water, and so we're looking at fusion from ice to water at 0 degrees Celsius. And after that, this 54.0 gram of water will undergo temperature increase until at the end the temperature is even. The final temperature is going to be X. So in this case, we'll say, well, the heat gain of the ice cubes will be from the heat loss of this hot water. So let's set up the equation. The heat gain of the ice cubes, 54 grams divided by the molar mass of water, 18. So we have actually 3 moles of water, and to melt 3 moles of water we need to multiply 3 moles by 6020. We need this much heat, 18,060 joules to just melt the ice. Alright, so this is how much heat that flows into the ice cubes to melt it. This number is useless. Alright, we don't really care how many ice cubes are there. As long as we know the mass and the molar mass, we get the number of moles multiplied by the enthalpy of fusion. We have the amount of heat required to melt the ice cubes. That's it. And then we further heat up the water, 54 grams of water, from 0 degrees Celsius to the final temperature. I'm going to use X degrees for the final temperature. Alright, so over here it's the ice first is melted to water at 0 degrees Celsius, and then its temperature is increased to X degrees Celsius. So these two parts together is the amount of heat absorbed by this 54 grams of ice. And now we have also 115 grams of hot water times 4.18 times the temperature change of the hot water is this. Alright, and everything together it should be 0, because when we mix this hot water, 115 grams of hot water and ice cubes, we mix them in an isolated container. There's isolated container means there's no heat flows in or out of the container. So we'll just set up this equation. Overall, the amount of heat that flows into the ice cubes is equal to the amount of heat that flows out of the hot water. So we'll just solve this equation, and that'll be it. Let me show you how to solve this equation. It contains only one variable, and therefore we can definitely solve this. We'll clean this up. This is just X. Alright, and over here there are 2 parts. So we have this times X, and we have this times 90. So we have this Alright, now I'm gonna remove the parentheses. So we need to solve this equation, and we can certainly combine this too, right? So this is a number times x, this is also a number times x, so we'll have this two combined times x. Alright, and now we're gonna move this to the right hand side, so equals this. We'll also move this part to the right hand side. I'm gonna just delete this, minus that. Alright, we'll just solve this equation. X is the right hand side divided by the sum in this pair of parentheses. Now I'll use another pair of parentheses to put everything together, and then divide it by whatever is here. Okay, this is how we set up the equation for x. X is 35.7 degrees Celsius.